We tend to think of the ground we stand on as, well, solid, permanent, right? But what if I told you that's not the case at all? Turns out the surface of our planet is actually alive. It's constantly on the move, reshaping itself right under our feet. And that's the story we're diving into, the incredible story of plate tectonics. And our story kicks off with a huge mystery. Check out this number, 90%. Over 90% of all earthquakes on Earth, they don't just happen randomly. They're concentrated in these really specific, narrow zones that just kind of snake across the globe. For decades, this was a massive puzzle for scientists. So you gotta wonder, right? Ever wonder why? Why there? What makes some parts of our planet so unbelievably active, so violent, while other parts are just calm? Well, finding the answer to that question completely changed how we see our world. All right, to crack this mystery, we've got to jump in our time machine. We're going back to a guy who spotted a pattern that almost everyone else at the time just thought was complete fantasy. And that man was Alfred Wegener. In 1912, this German meteorologist came up with this idea that was just totally out there. He said the continents themselves were drifting. He even suggested they were all once smashed together into one giant supercontinent he called Pangaea. And the scientific community, they laughed him out of the room. I mean, they basically ridiculed him because he had a big problem. He couldn't explain how. What force could possibly move entire continents? But here's the thing. Wegener had clues, and they were really compelling clues. I mean, just look at a map. He saw how the coastlines of South America and Africa fit together like a perfect puzzle piece. Then he found these identical fossils. We're talking freshwater reptiles that couldn't possibly swim across an ocean on totally different continents. And on top of that, he noticed that huge mountain ranges seemed to just continue across the ocean. The evidence was stacking up, but he was still missing that crucial piece, the engine. The how was still a mystery. So, can you believe it? Wegener's idea was pretty much ignored for over 50 years. Then, boom, the 1960s roll around. We get all this new technology that lets us finally map the ocean floor in detail. And what do we find? Something incredible called seafloor spreading. Basically, new crust was being created, born right in the middle of the ocean, pushing everything apart. That was the missing engine. And just like that, the theory of plate tectonics was finally accepted. Wegener was right all along. Okay, so with that puzzle piece in place, we can finally understand the how. It turns out the Earth's entire crust is broken up into these massive, rigid plates, and they are all moving. And what happens where they meet at their boundaries is actually pretty simple. It really boils down to just 3 basic interactions. They can smash into each other, they can pull apart from each other, or they can grind sideways past each other. That's it. Collide, separate, or slide. And these 3 simple movements are responsible for almost all the dramatic geologic action on our planet. So let's break them down. First up, convergent boundaries. Think of this as a planetary head-on collision. 2 plates are moving directly toward each other. And when 2 massive continents collide, they can't go down, so they have nowhere to go but up. They buckle and crumple, creating absolutely massive mountain ranges. We're talking about the Himalayas here. This is where you see some of the most powerful forces on the planet being unleashed. Next, we've got the total opposite, divergent boundaries. This is where 2 plates are pulling apart, and as they rip away from each other, hot magma from deep within the Earth's mantle rises up to fill that gap. It cools, solidifies, and creates brand new ocean floor. It's pretty amazing, actually. It shows how the Earth is constantly renewing itself. A perfect example is the Mid-Atlantic Ridge, this giant seam running down the middle of the Atlantic Ocean. And last but not least, we have transform boundaries. Here, the plates aren't smashing together or pulling apart. Nope. They're just grinding past each other, side by side, like 2 giant pieces of sandpaper. No crust is created, none is destroyed, but man, the friction is just immense. Stress just builds and builds and builds for years, sometimes centuries, until, snap, it releases all at once in a massive earthquake. And if you're thinking of an example, the San Andreas Fault in California is the poster child for this kind of action. Now, of those 3 types of boundaries we just talked about, there's one that is by far the most powerful and the most destructive. We're talking about the planet's main factory for monster earthquakes. This is the subduction zone. So, what is the subduction zone? Well, it's a special kind of collision. It happens when a heavy, dense oceanic plate crashes into a lighter continental plate. The oceanic plate loses that battle and is forced to dive down, or subduct, underneath the other one. And as it sinks, it actually drags the edge of the top plate down with it, like bending a ruler. This builds up an insane amount of stress. And this one process is responsible for the deepest trenches in the ocean, the most explosive volcanoes, and yeah, the most powerful earthquakes the world has ever seen. And I mean, just look at the raw power we're talking about here. The biggest earthquake ever recorded, a 9.5 magnitude in Chile. The absolutely devastating 2004 Indian Ocean quake and tsunami. The 2011 Tohoku quake in Japan. All of them were what scientists call megathrust earthquakes. That's the name for that sudden, violent release of centuries of stress built up in a subduction zone. These things really are the planet's earthquake factories. So what happens if you take a map of the world and just highlight all of these superactive boundaries, especially all those subduction zones? Well, a really dramatic pattern starts to emerge. A huge, connected feature that's so active, it's earned itself a very famous and very fitting name. This is the Ring of Fire, and it's enormous. We're talking a 40,000-kilometer-long horseshoe of nonstop geologic action, wrapping almost all the way around the Pacific Ocean. It's not just one single line, either. It's this huge interconnected network of different plate boundaries all grinding and crashing into each other. And here is where it all comes full circle. Remember that number from the very beginning, that 90%? Well, here's your answer. About 90% of all the world's earthquakes happen right here along this one feature, the Ring of Fire. And it's not just earthquakes. The Ring of Fire also hosts more than 75%, 3/4 of all the world's active and dormant volcanoes. So yeah, without a doubt, it is the most geologically dynamic and powerful feature on the entire surface of our planet. Okay, so at this point, we know where the action is, the Ring of Fire. We know how the plates move, they collide, separate, and slide. But that leaves one last, really deep question. What is the actual engine driving all of this? What force is powerful enough to push and pull these continent-sized slabs of rock around the globe? You know, for a long time, scientists thought the answer was something called mantle convection, basically slow-moving currents in the hot rock beneath the crust, kind of like a giant conveyor belt. But it turns out that's only a small part of the story. The real primary engine, the main driver, is something called slab pull. Imagine you have a heavy tablecloth on a table, and a big part of it is hanging off the edge. The weight of that hanging part will start to pull the rest of the tablecloth off the table, right? That's slab pull. That cold, dense oceanic plate that's subducting and sinking deep into the mantle, its own immense weight is literally pulling the rest of the plate along behind it. The sinking plate is the engine. So the next time you're just standing around, take a second to think about it. The ground under your feet feels solid, but it's not. It's the skin of a living, breathing planet. Continents are shifting, new oceans are being born, and mountains are still rising, all in super slow motion. It really leaves you with a final thought, doesn't it? The ground beneath your feet is moving right now. In fact, it's moving at about the same speed your fingernails grow. So where do you think it'll be in, say, another 50 million years?